In this lesson, we're going to be talking about triangle congruence with angle, side, angle, 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 side, and no ASS. So I'll clarify what that is referring to later in the video. To start off, let's do a warm-up. Pause the video and see if you can select the correct option before I go into an explanation. We want to determine which postulate determines that the triangles are congruent. So hopefully you said side, side, side. You can see that all three corresponding sides are congruent to each other, which makes side, side, side the best answer. Today's objectives are going to be to ultimately write a congruent statement again for congruent triangles, this time of course focusing on the postulates and congruence postulates or theorems that we've otherwise haven't talked about yet. And we're going to be proving triangles are congruent all the same. So we're going to review a bit from what we did in the last video, or last lesson, 4.05, practice problems. We're going to talk about two more congruence postulates, and then we're going to talk specifically about that funny little word at the beginning that doesn't represent a congruence postulate whatsoever. And then we're going to practice problems, and we have your exit ticket assignment 4.06. So let's start from what we did in the last video. We talked about side, 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 side angle, side, and the right hypotenuse leg congruence postulates or theorems, right? So just as a reminder for side, 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 remember we want to reference the fact that you need all three corresponding sides to be equal in length, whereas with the side angle side you have to have two corresponding sides and the angle in between. And just keep in mind, additionally, the angle has to be included. That's what it means to be between when you're identifying side angle side. And then lastly, of course, with the hypotenuse leg, you have to make sure that you have a right angle, which means it's a right triangle. And of course, you're identifying the hypotenuse and one leg are equal to a hypotenuse and one leg of another triangle. So let's go ahead and practice this together here. We want to write two congruent statements for the congruent triangles below, and we want to circle which of the congruence postulates or theorems is viable for this particular example. Here we can see that there is a leg that is clearly labeled here and here, and we also have a hypotenuse labeled here and here. So this is a leg, this is a leg, this is a hypotenuse, and this is a hypotenuse. So that means that the hypotenuse leg congruence is going to be the acceptable answer in this example. Now we want to write the congruent statement. I can start by writing triangle ABC, and I want to make sure that I match up the corresponding angles with ABC. Triangle XYZ is oriented the exact same way as ABC, which makes this very simple to identify. The triangle is going to be XYZ. Now I want you to pause the video and see if you can identify which of the three best represents the answer to this particular problem. You also want to take the time to write the congruent statement after the fact. So this example is what I like to call the bow tie example because it looks exactly like a bow tie. What you have to recognize is that we have two sides that are clearly labeled, but we also want to point out that there's angles here that also happen to be congruent as well. And we remember that these angles are vertical angles. We can identify that angle ACB is congruent to angle DCE. Notice that C is the middle letter in both of my statements. So as a result, we can see that they're both congruent to each other, and the reason for that is because they are vertical angles. Now the reason then why the two triangles are congruent, you can see that there's a side and an angle and a side, an angle, and a side. So the postulate that needs to be used to identify why the triangles are congruent is the side angle side. In this case, I already wrote an angle statement above, two angles being congruent to each other, and I can use that exact same order to write out my congruent statement, ACB and DCE. So let's go ahead now and focus on the others that we have. So the ones on the far right are the angle side angle and the angle angle side. In this particular case, with angle side angle, two triangles are congruent if two sets of corresponding angles and the included sides are actually equal. So you have two sets of corresponding angles now and a single included side. So now it's the reverse of the side angle side. Now we have two angles and an included side instead. With angle angle side, you do have two pairs of corresponding angles, and you also have a non-included side. So I'm going to point out that it's supposed to be a non-included side as opposed to an included side. These are two additional congruence postulates or theorems that we can use to justify why the triangles, if they are presented to us, are congruent. So now, when we look at all of these are what we've compiled so far that allows us to justify why triangles happen to be congruent to each other. You can see that it might be important then to recognize when we can identify corresponding angles and sides, why that's important, and to identify included versus non-included angles. Let's practice this for a little bit. We have two triangles here, and we're going to identify which of the reasons justifies why they're congruent, which of the congruent postulates or theorems, and we're going to write the congruence statement as well. So in this particular case, we have two triangles, and if you want, you can even draw them out separately. So just making random drawings here with the two triangles that I have. Alright, so they've marked this angle and this angle with 1 and 2 arc marks, and this angle with 1 and 2 arc marks respectively. And they've also labeled that this side has a single hash mark and this side has a single hash mark. So just looking at the triangles, not necessarily what's the labeling just yet, you can see that there is an angle and a side and an angle and a side and an angle. So it spells out the very reason that we have to use to justify why they are congruent. Angle, side, angle. Now, having said that, it is also important to recognize that indeed it is true that you have other justifications that you can use as well, right? You're going to find that that's actually very, very true. For example, you'll notice they both share this side length down here at the bottom, and I did point out in the previous video that oftentimes we want to reference that anytime there's a side that is shared, that is automatically congruent to itself. That's technically due to a property called the reflexive property, and that allows you then to conclude that the triangles are congruent by side angle side as well, which is in fact the case, right? We could certainly label that, and we could use side angle side. However, this one also allows us or permits us to use the angle side angle, so it's an example of using a different postulate to get the result that we want. So in terms of the congruence statement, the triangle that we had here was triangle LKJ, and this was triangle MJK. So the triangle LKJ is congruent to the triangle MJK. That's my congruence statement. So what I would ask you to do is to pause the video now and see which of these could justify why the triangles happen to be congruent to each other. So the best answer is going to be the side angle side. We want to be very careful because the moment we see right triangles in our diagram, we might think that the hypotenuse leg is appropriate, but we don't actually want to make any assumptions until after we've examined all the facts that we now know. It is in fact true that this is the side that is shared, so we can certainly state that WZ is congruent to itself, and we know why. We know and we understand that it's the same segment, so it has to be congruent to itself. Now, having said that, we have two triangles where we have a side and an angle and a side, an angle, and a side. So that's why side angle side ends up being the best justification in this case, not the hypotenuse leg. The hypotenuse is located here and here, XC and YC, but they're not labeled. Even though I could prove that they're congruent, they're not labeled, and what we want to do is anytime that we have a reference to something where you have the segment being shared like I do here, that does trump other things typically. We want to automatically understand that they're congruent to each other. You don't have to actually show anything to prove why those are congruent to each other. They are congruent by a property that I mentioned earlier. You'd have to show that xz and yz are congruent, and then you'll have the ability to use certain theorems then that can then justify that as well in the future. So right now, the side angle side is the most apparent of all of them, and then some of them, of course, don't really necessarily work as readily or as apparently as the others do. So side angle side. So let's take a look at this example here. We have two triangles. They're not sharing anything, so there's no reflexive property at all whatsoever. And we're looking at the diagram, and what I go over here and I want to do is I'm just going to label things. I have angle, I have an angle, and then I have a side. And then I have an angle, and I have an angle, and I have a side. So I'm going to notice that the side that's labeled is non-included. The side is non-included. That tells me with the two angles on the side that the best option here is going to be angle, angle, side. So that's an example of the angle, angle, side and what it might refer to. So if I write triangle ABC for my congruence, I know that it will be congruent to triangle X, Y, and Z. Again, those are corresponding vertices in each triangle. That's why it's arranged the way that it is. So now what I would do is pause the video and see if you can identify the correct reason why the triangles happen to be congruent to each other. So in this case, we can see from the labels as well as from the congruence statement as well what angles are corresponding. And I'm going to go ahead and label what I see. I have an angle and a side and an angle. I have an angle and a side and an angle. So once again, I can see this one would be proven congruent by angle, side, angle. It's really nice when you're able to spell out the actual justification on your diagram as well. That can be very, very, very helpful. So let's talk about this particular one, which does spell a bad word if you spell it a certain way, right? Depending on the orientation that you spell it in. And so we're going to refer to it, and I certainly will refer to it as side, side, angle. But having said that, it's a bad word. We don't allow it. There's no donkey postulate whatsoever that justifies why two triangles are congruent. Now, if I'm being completely honest, that's not entirely true, and I'm going to show you why that's not entirely true. If I go back to an example that used hypotenuse leg, and I don't know if I had one here or not, but we can come up with one. If I have to make one myself, I will. So let me just kind of draw hypotenuse leg here for a second. We have a specific name for hypotenuse leg. This is true. But we call it hypotenuse leg because it more readily allows students to recognize that it is a right triangle pair that you have to have. But let's say for the sake of argument that we have two triangles that are right triangles. Technically, if I use my labeling system, we have two sides, two pairs of sides, and we do have a non-included angle. And that's actually always going to be true, by the way. And it does spell out that very same word. So technically, there is a side-side angle. However, we don't call it that. It is the hypotenuse leg. And also, it's a special case, right? It only works for right triangles. It doesn't work for all triangles. So that's why ultimately we say that it does not exist. So please, 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 we never want to see you use ASS or SSA as a justification for why two triangles actually are congruent. If you're going to justify this, we would rather you say hypotenuse leg, and you can only use that if they're right triangles. Otherwise, again, you're kind of stuck with the others that we have. So a little chuckle for the moment. Now, obviously, it can be easy to be tricked or otherwise fooled. They can oftentimes look similar to other statements, right? So you have to be able to identify the differences, right? So if you look at the first pair up here on the upper left, there are three sides for every triangle marked. So that is very clearly side, side, side. This one right here has the two angles. It's actually got a dot here instead, but I'll go ahead and put an arc. That is angle, side, angle. This one right here, two angles and a side. So two angles and a side. That's angle, angle, side. Sometimes it helps to go around the triangle and label as well. That's perfectly fine. It spells out what we're looking at, especially if you're writing it in the correct order there or you're writing it next to it. Angle, angle, side, angle, angle, side. This is one where it technically is SS. It can be SSA, but we refer to it as hypotenuse leg because it's specifically a restriction on right triangles only. So a lot of times we label that with hypotenuse leg, and then this one is where people often get fooled, the one right here, because you can see that it has angle, side, side, angle, side, side. People are like, oh, that they're congruent because of angle, side, side. Or side, side, angle. No, right? If you spell that out, if you end up with that, this is not enough. Not enough info. There's not enough information to prove that those triangles are congruent based off of that. This last one here, we have side angle, side, side angle, side. So all of the others are justifiable and justifiably congruent, but not that middle one on the bottom row. So having said that, let's take a look at this example. It is possible to be given triangles where they may not in fact be congruent whatsoever, and this is a prime example of that. So if you look at the two triangles, we have an angle right here, and we're given a side, and because they share this side in the middle, US, you can see that by the reflexive property, it is congruent to itself. We know that. And that unfortunately gives the bad word, right? The angle, side, side. It has the non-included angle and the two sides. So this is not congruent, and the reason why is because there's not enough information, right? You can say, not enough information, or justification, since side side angle or angle side side doesn't exist, right? We know that that's not an actual postulate or theorem that justifies, so we have to be very clear about that here. So what I would ask you to do is to pause the video and see if you can identify if these triangles are congruent, and of course if they aren't, you say not enough info, and then select the best option in this case. So here you have hypotenuse and a leg because it's a right triangle pair. Hypotenuse and a leg, so the best answer is hypotenuse leg. They are in fact congruent given that example. So if I look at this example right here, we have an angle and a side. And these angles here are going to be congruent to each other because they're vertical. So in that particular case, we could say that angle RTS is congruent to angle VTU, and the reason is because they are vertical angles. Vertical angles. So I spelled out angle, side, angle. That would be the best justification here as to why they are congruent. Sometimes we say vertical angle theorem for the justification specifically. So I kind of abbreviate that as VAT, but it stands for vertical angle theorem. That justifies why they are in fact congruent to each other. We've already discussed those types of angles in the past. All right, so go ahead and fill out this last one here. Pause the video and see if you can come up with the response. So if you said not enough info, you would be in the clearing here because side, side, angle, angle, side, side doesn't exist. There is no such postulate or theorem that otherwise justifies this, and you can see it's two sides and a non-included angle, so that is the reason why these are not congruent. Okay, so just remember that this video talked about the congruence of triangles, this time introducing the angle side angle, angle side, and of course no angle side side, no donkey whatsoever. All right.